Hello. Uh, Today we're going to wrap up all the detail about lecture folder lecture 1 and 2 together, and also present you with the homework and all possible take-home exam. Okay. So I did prepare you a file here. Okay, contained it in folder lecture number 2, okay, on my Google Drive, okay, that here they call 01206621, okay, homework and take home, okay, you can get in and just look at in the under Google Doc platform, okay, and we go ahead and get started and give you some example of all the possible homework. Some of this, if you did follow the detail from the very first clip, okay, okay, you probably see that I did mention some of this during the lecture, okay. So let's look at the lecture number 1, okay. You might recall on my online learning, okay, the folder lecture number 1, okay. In lecture number 1, okay, I'm gonna increase the voice level a little bit. Okay, okay. We do have this Excel file, okay, of I think that we have large LP test, okay, and also the store diet, okay, store diet dot, and also Dan6 LP uncertain, okay, the 3 files, okay, they're related to the Excel platform, okay. And first of all, the file large LP test XLSX, okay, you can go ahead and increase the number of scenario of the case study, okay, contain, which is have a main 6 variable in the first stage of the 2-stage model, okay, and then you can keep running solving the problem using OpenSolver, okay, until you feel that OpenSolver reach the limitation of your computer, okay, which can be 2 cases, okay, that okay due to memory, okay, memory running out of memory, or you keep it all night, okay, and keep running it all night, but once you wake up in the morning, the solution still got stuck. They didn't get the result yet, okay. And then you use that example and trying to use Bender decomposition to solve, okay, okay, and show that is it possible that the Bender approach can be feasible, okay. And also after that you can, okay, keep expanding the size of based on the number of scenario, okay, until using the Bender approach until, and also at this moment you can also increase the number of decision variable in the stage 1, which in this example we use only 6 variable, okay. You can increase it, and you observe the behavior. I think in the second stage, in the second question here for this file, you can do both on open solver, which is expected to be open source, and then you can use it to check if you increase the number of variables in stage 1, okay, and you fix the number of scenario, okay, how you what you want to see is that the number of vendor cut that's going to be increased. uh, is it have any effect? Because if you might remember in this file, we use up to 80 iteration, okay, showing in the file, okay. And to do this, okay, I think that you should familiar with developing the VBA Excel, okay. If you're not comfortable with this approach, okay, you might go ahead and try to do it under the Matlab or Matlab lookalike or software instead. Okay. Okay. The second file is a store diet and a copy of store diet with raw 6 added. Okay. That's okay. Is this file the store diet, and also you have this one, the store diet. Uh, uh, yeah, you have store diet here, and this one you have copy of store diet raw 6 added. So there's four Excel file in lecture number 1 folder. Okay, and you can do the same. Okay, with these two files. Okay, and also the third question, third problem that you can do is that uh, once you use the Bender decomposition, okay, it's not directly you can find the optimum dual variable for the main problem. Okay, and we did talk about the approach. Okay, in some clip related to lecture 1, how to find the optimum dual. Okay, and I think that in the file of the copy, this one, I think this one, copy of store diet raw 6 add. Okay, we have added some of the illustration of how to find the optimum shadow price. Okay, under the Bender approach. Okay, okay, and certainly you can go back and did this to the file of large LP test also. Okay, apply this knowledge. Okay, and then the last thing that from the Excel platform in lecture from lecture 1 folder is that you can go back and look at the file of Dan6 LP uncertain example here. This one we illustrate how to use Excel to solve the problem example 2, right? This file is for example 2 from the paper, classical paper of Dan6. Okay, but we just want you to extend this idea to solve the example 3. Okay, we extend the use of the file here to solve example 3. Okay, this file was developed to solve example 2. Okay, that be the first Excel platform from folder lecture 1. Okay, we can now extend to lecture 2 that related to the production planning and control under uncertain demand. Okay, and we have the first file is in the lecture 2 folder. Okay, it's belong to this one, the PPC with under uncertain demand here. Okay, and we you can go because this file have not finished solving the problem yet. Okay, you can finishing Bender decomposition in sheet 2 and 3 and do the same as mentioned. Okay, in just like the question mentioned in the for the file a large LP test. Okay, from lecture 1 folder. Okay, and also find the corresponding dual variable, the shadow price, in case that you have to know that if you want to find the optimum dual variable. Okay, you can do it only in the case of continuous LP. Okay, once you enter the mixed integer programming, okay, there's no way you can find the optimum. There's no dual variable. Let's just say that. Okay, no optimum dual variable. Okay, so in case of fixed charge model, okay, you don't need to find it. You just find only for the variable, the linear cost problem. Okay, and then you solve the problem from the file homework take home exam. This is a new file that I add. Okay, here. Okay, I'll show you a little bit. Okay, this is a new Excel file. Okay, that I did make it, that we have 12 period. Okay, we do have 12 period of take a while to load the file, for my slow computer at home here. Okay, but you can look at on your screen that you have a 12 period problem. Okay, 12 period problem. Okay, for each period, okay, you can have okay, I'm gonna expand it. Okay, so you can see it better. Okay. Okay, so this is a time varying, no, the time varying cost per unit of production and ordering. Okay, so in each period, there's no, it's not a constant uh, cost per unit. Okay, for in each period, and in each period there are five possible alternatives. Okay, let's just see. In period one, you have can have either 40, 41, 42, 43, 44. And there's some corresponding table, okay, to link what we call the probability that each for each alternative can happen in each period. Okay, like this one. Okay, for 40 in the first period. Okay, there's possibility of the 0.1 or 10% chance that the demand 40 can happen, and 20% for 41. Okay, and 40% most likely for 42, and then 20% for 43, and end up with another 10% for 44, for the amount of 44. Okay, and we do have for each you can analyze this problem in two cases. Okay, the S is a setup cost per unit, or this one it can be you can say that it's a fixed charge in okay, not the variable cost, but it's a fixed cost or setup cost that can happen when you place an order. And this one is H, small h is a holding cost per unit. Okay, okay, per period. And G is a back order cost. Okay, or you can say that is the cost when you want to, when demand is greater than supply, you want to fulfill the remaining amount. Okay, and you can see that this one have a different assumption for all the example that we mentioned before, because for all the problem that we've been solving so far, we do assume that each random variable have a uniform distribution. Okay, which means for discrete random variable, all probability are all equal. But now you have a different type of probability, kind of empirical probability. Okay, for each period. Okay, for for demand in each period. And also in practice, okay, the number of alternative, okay, in each period might not be equal. Okay, yeah, but in this one we try to simplify for you. And also the holding cost and then back order cost here can be different period to period. Okay, it doesn't have to be a constant value, and the same as a setup cost. Okay, if you might recall from the example of Wagner-Wittin paper, the setup cost in each period is not equal. Okay, so this one is a kind of we trying to set up some numerical example, and with the knowledge that you learn from the clip, for all clip that related to lecture 2, you should have sufficient knowledge and skill and also the tool to solve this problem. Okay, so that's the new problem that we add here. We solve the problem here. Okay, for this file. Okay, and also for the MILP approach, the mixed integer linear programming, okay, you can use operator solver to solve it in case of fixed charge. Okay, and we do have some Excel file from this sheet. Okay, like in the sheet called Wagner-Wittin model here. Okay, on at the bottom right. Okay, on the screen here. Okay, the Excel related Google Sheet file. Okay, you can find the limitation when you using open solver. Okay, to solve Wagner-Wittin model. And then you can see that if you do apply the Bender approach, this one is not the under uncertainty. It's just do it directly under the deterministic demand, but time varying demand. Okay, but is Bender become a good approach when the problem getting larger? So this is a research question here to ask, and then you want you to do some experiment and do some comparative study. Okay, actually this question, I think that if you go and try to find some old research work, okay, somebody might have been done it. Okay, because this is a well-known I think results that okay, in some case Bender can be uh, more efficient. Okay, when the problem size getting larger. But certainly there's some competition about this also if you using the direct dynamic programming to solve it. Okay, but all have to be under the assumption of Wagner within in the paper. Okay, you might remember that there's some certain assumption need to be satisfied, okay, in order to use the direct dynamic programming functional equation to solve it. Okay, and okay, the last one from the Excel file, okay, from the very last lecture that I gave you in the Bowman uncertainty file here, the Excel file here. We did the unfinished job, okay. We haven't finishing the problem from the file Bowman uncertainty yet, okay. You can finish it off, okay, and submit it uh, as your work, okay, to fulfill the requirement and evaluation of the course. Okay, that be all, okay, for the first two slides, okay, that under the Excel platform, okay. Uh, you can do it all, or you can, there are many, or you feel it's too much, you still have another course that you need to uh, spend your time to do homework. So feel feel free to choose whatever you want, you can do, okay, and try to do your best and submit your work, okay. And now we're moving to the Matlab platform, okay. Probably the question is almost the same, but using a different platform. But also the related file have been different because like in in the lecture one here, okay, folder, okay. We have a related file of Matlab here, okay, the Bender store diet, Bender two-stage LP, Bender two-stage LP, and direct LP. And also we also have a direct example SLP here. This is the Danzig's name, also the refer to the corresponding problem solved, okay, using the Excel. We call direct LP uncertain example also. These two files have the same, solving the same problem, but using different uh, platform, okay. And also the last file for the Matlab file is a two-stage uncertain, okay. And this one is we call the I almost what the two constraint coefficient, okay, which we try to generalize for m by n original LP, okay, when you add some uncertain scenario, okay. And here the first one, we find the limitation of using direct LP example. This is similar to what we try to do with OpenSolver under the Excel platform, okay. And we want to use this to solve the related problem directly, compare it to using the file Bender two-stage LP example as the number of scenarios generated grows, okay. In this one, we fix the number of the decision variable of the first stage with only 6 variables. You might remember the problem, the very first example problem that we saw. Okay, but now just trying to compare whether the direct approach and the bending approach, is there any different and limitation? Okay, when we certainly the limitation will be different because you're using different type of hardware, each of you. Okay. And then the second one is an additional one based on the tools that we already developed. Okay. Okay, we repeat the previous question by adding x7, x8, x9, x10 one at a time. Okay, you can one by one. This means that you can keep for the original x1 to x6, you add x7 for happen, x8, x9, and then x10. Okay, and with this coefficient, okay, formula. Okay, this one the formula. Okay, with the Matlab format. Okay, for the Excel, you don't need to identify the seed number here. Just so this one according to the formula of Matlab. Okay, respectively. Okay, this one this four variable respectively, one by one linked to x7 to x10. Okay, okay, with 3 digits precision, the same precision as a previous data, and observe the number of bender cuts. Okay, yeah, you remember we kept the number of bender cut in the variable called icons. Okay, icons generated here. Okay, and total computing time as the number of decision variable in the first stage, which means that if you did the first question under Matlab form, this one. Okay, this one is a 6 major first stage decision variable. Okay, so this second question want to you to observe that once the decision start to increase one by one, 6 to 7 to 8 to 9 to 10 in the first stage. Okay, uh, we want to observe the number of bender cut that increased. Okay, can be increased and go as compared to the number of scenario go. Also, we already saw in the first example that once you increase the number of scenario without increasing the number of decision variable in the first stage, a lot of time the number of bender cut do not sensitive with this increment. So it's mean that's the whole idea that Blender is so efficient, okay, to solve this type of problem. But you will see that when you increase the number of decision variable in the first stage, you end up having to spend more time, okay, because your number of Blender cut will be increased. So as the number per iteration, okay, which means per Blender cut, because once you when your scenario grows also. Okay, so we repeat the first question with 5 bender. Okay, when you extend this problem to the file of the diet problem and modify this file to handle the case when raw material added, because we already have this is one is more realistic example with the stochastic two-stage diet problem. Okay, actually, with this problem, you can so if you already did some automatic Excel macro with the spreadsheet platform, okay, you can also repeat doing this problem for the Excel platform also. Okay, so not finished yet for lecture one. Okay, you might conduct experiment comparing solving the problem between using file Blender two-stage LP, okay, and file two-stage LP uncertain coefficients, okay, as MN and capital N grows, okay. If you might remember the Blender two-stage LP, okay, this is just a direct application with the first example. But this one is two-stage LP uncertain coefficient. M is more like if you can expand. Actually, there's only one main constraint in the first stage. Okay, with uncertain cost, with uncertain constraint coefficient for this file, Blender two-stage LP dot M. But for two-stage LP, uncertain M is more of a, you can have a M constraint and N variable for the under deterministic case, and then you can add some of the uncertain parameter for the constraint on the right hand side with this M constraint and N decision variable on the first stage. Okay, and then with the additional, okay, uh, variable once the N capital N grows. Okay, so this one is kind of repeating what we did on this under this just like what we did here. Okay, but this one is just for uh, yeah, it's only for the Blender example here. Okay, I think I did mention wrongly about Blender two-stage LP.m. Okay, we're going back to see what this program look like. Okay, Blender two-stage LP. Okay, .m. Okay, okay. So this one is also the Blender approach. Okay, to solve the for the case of uh, when you have a number of the mn small mn also. The difference between this one and for the two-stage LP, this one, okay, is that okay, sorry, this one two-stage LP uncertain constant is you solve this directly, okay, by using the lin prop, okay. Okay, you might go back and take a look at that. The two-stage LP uncertain coefficient is you solve the direct model, okay. Then use the Bender approach, but this one we use the Bender approach. Okay, so this file should be more efficient than this file, and you need to conduct experiment to illustrate that claim, okay. And also you can add code determine the optimum dual variable. This one is similar to what we mentioned under the Excel platform, okay, to these two files, okay, for both Bender file here, okay, because you know that for the direct approach here, that you can you can use Matlab to show you the optimum dual variable directly, okay. So this problem also similar to what we did under Excel platform. Okay, you can use this file. Okay, the MATLAB file to solve this one. Solve the second example on the DAM6 paper, but we want to extend this to solve example 3 in the paper. Okay, and in summary here, you can conduct comparative study between Excel and MATLAB in all cases. It means that if you're using Excel, you need to be able to develop the VBA macro, okay, and to make it automatic and compare to the MATLAB coding that we develop. And also with additional, if you can be extended, okay, modify the program to handle all the additional questions that we did recommend you to do, okay. Okay, so we are moving now to the final, okay, page of the take homework and take home, okay, that's still related to the MATLAB platform of lecture 2, okay. This one related to the Bender with the fixed charge problem, okay. Okay, this one is the test coding of a Bender PPC and test coding fixed charge, okay. Test coding is mean that you solve the direct model, okay, not using the Bender. Okay, you can see that and in this one we just try to direct the code to the example, okay, rather than trying to make it a more general. So you can modify this file to handle in terms of general case, when you can set the number of scenario and also you'll be able to generate the related data. Okay, once the assumption of each scenario, each is scenario according to the randomness of the system parameter. Yeah, the second one, you can conduct experiment comparing solving the problem between using file. Okay, this one just okay, for Bender here, okay, it's related to Bender. This one is we use the test coding Bender PPC compared with Bender PPC when set number of scenario, okay, as T, the capital T, and NSC is the number of scenario, okay. T is the number of period, okay, don't confuse this with the another T that related to the Bender cut model, okay. T is the number of period, okay, and then number of scenario grow, okay. Okay, you're not going to be able to solve this one for the first file here when you already modify the file here, the first question, okay. But in this one, it's automatically can be handled with this situation very easily, okay, for Bender course. Okay, and also you can conduct experiment comparing solving the problem in case of fixed charge, okay. Okay, when the same as when the number of scenario and number of period increase, okay. It was expected the fixed charge case will be more difficult to solve. It means that the limitation of the program should reach in a lower amount of t and number of scenario. Okay, and this one also we did talk about it. You once you develop the Bender, okay, to solve the Wagner-Witten, okay, under Excel format. You can do it under Matlab format also. Okay, the Matlab course. And also, this is a big case for the Bowman uncertainty. Okay, you might remember this is a quite an open question, and can be group. Okay, some of you might combine group and trying to, because I didn't develop this code for you. Okay, but I do expect that with all the example that I show you, this is the thing that you should be able to do. Okay, that you develop your own Bender decomposition when applied to the Bowman. You know that Bowman just only have a illustrated example in the Excel format, and we just solve for a few iterations. Okay, so the first one under Excel platform, you can finish that problem using the Excel format. Or the second one after that, you can generalize and make it a MATLAB code, and then you can conduct some experiment study, future experiment study, and comparing between using the Excel macro or using the MATLAB coding in all cases. Okay, so this is there's still not much question that I raised for you about the radical problem. Okay, so most problem that I recommend you to do here is more like a computational development. Okay, for solving extensive case based on what we have studied so far. Okay, so that's about it. Okay, to wraps up all the summarized homework that I expect you to fulfill. Okay, the requirement of the courses. Okay, so choose uh, certainly my ideal expectation is that you can do it all. Okay, but I know that it's not uh, within the time constraint of the courses. I can't expect that you to finish all of this. Okay, but you just try your best and do as much as you can. Okay, so that wraps up the lecture 1 and 2 here on my this one. Okay, next time we're going to start with the uh, lecture 3 here. Okay, in the clip number, starting from clip number 25. Okay, see you. Okay, all. Okay, pretty soon.